Hello everyone and welcome back to Leetcode. Today we're doing problem number 62, unique paths. The problem here is that there is a robot on an m by n grid. The robot is initially located in the top left corner, grid 0, 0. The robot tries to move to the bottom right corner, grid m-1, n-1. The robot can only move either down or right at any point in time. Given two integers m and n, return the number of unique possible paths. So, apologies for any noise, I've got my window open because it's a gazillion degrees, but it's a busy road outside. Okay, so here we can go all this way, or any sort of staircasey model in between. On the one hand, we can generate them all and count them, but that feels unnecessary. If I'm generating them all, that's just expensive. And it feels like there should be a nice recursive solution here. So for example, hang on, let me work over here. If the grid is 1 by 1, there is one path. If it's 2 by 1, there's one path. If it's 1 by 2, there's one path. If it's 2 by 2, we can go do, or we can go do. There are two paths. If we extend this across to go 2 by 3, what that does is it gives us all the ways we can do. No, hang on. I don't know if there is a nice recursive solution here. You can go that way, you can go that way. So you can go here and you can enter. So if you go here, you're in a new 2 by 2 grid. And then you're going to do that. But if you go here, you've got one option. So that's 2 by 2 plus 1. Whereas if it's a 3 by 2, if you go down, you're in a It's a 2 by 2 again. Goodness gracious, motorbikes. If you go across, you then need to go down, but there's only one way to go. So that one's 3, and that one is 3. Does that make sense? 1. Yeah, it does, because that's what that answer is. So 1, 2, 3, 1, 2, 1, 2, 3. Now if we were to go up to a 3 by 3, well, we can treat that as a 2 by 3 by 2. Well, no, that one's a 3 by 2. You have one 3 by 2 entry. You have another way to enter into a 2 by 2, plus another way to enter into a, oh, that's a 1 by 2, isn't it? So that's what each of those are. So a 3 by 3 is a 3 by 2, which is a 3 plus a 2 by 2, which is a 2 plus a 1. Which is 6. What does a 3 by 4 look like? 3 by 4, well again we've got our 3 by 3 structure. We've got one way into that. It's a 3 by 3 plus a 3 by 2 plus a 3 by 1. Ooh, 3 by 1. Hang on, so an m by 1 is always 1. And 1 by n is also always 1. So 3 by 3 is 6 plus a 3 by 2 is a 3 plus a 3 by 1 is a 1. That's 10. So hang on, a 3 by 7, which is what we're looking at here, should be a 3 by, so this is a 3 by 7, well it's a 3 by 6. Plus a 2 by 6. No, hang on, it's a 6 by 3, 6 by 2, 6 by 1. I don't know what a 6 by 3 is. So hang on, let's call it a 3 by 6. So I realize I flip-flopped my notation here. That's a 5 by 3 plus, oops, that should be a 2. Plus a 5 by 2 plus a 5 by 1. So that should be a 3 times 5 is a 4 times 3 plus a 3 times plus a 4 times 2 plus a 4 times 1, which is a 4 by 3 is a 10, a 4 by 2 a 4 by 2 is just going to be 3 by 2 3 by 1, isn't it? 3 by 2 is a 3 plus 1. That should be a 4 plus a 1. 10 is 15. 3 by 5 is a 15 plus a 5 by 2. 5 by 2 is a 4 by 2 plus a 4 by 1, which is a 4 plus a 1, 5. I realize I'm doing this the very, very long way. I'm sure there's some routine here, which I'm going to spot in a second. Plus 1 is equal to 21. 6 by 3 is a 21 plus a 6 by 2. 6 by 2 is a 5 by 2 plus a 5 by 1, which is a 5 plus 1 is equal to 6. 6 plus 1 is equal to 28, which is what we're after. Excellent. So I can never remember the keywords for this. Hang on. If m is greater than n, temp is equal to m is equal to n is equal to temp. all this does is ensure that m is less than n. So now we're in this case here. In fact, no, hang on. If m is equal to 1, return n. If n is equal to 1, return m. Oh my god, it is so noisy outside. This is ridiculous. Otherwise, what we want to do is, if we're doing something like that, we want to do for I is equal to 1, I is less than m, I plus, let tot equal to 0, tot plus equals unique paths, m minus, this is I, m minus 1, tot. What I really want to do is cache this in some way. You know what I should have done? I should have done this in Python. Because then it's nice and easy. Let's quickly switch to Python. Keep my notes around. So these all need a hash. Bugger. Let's stick this all in just giant quotes. This editor tries to be helpful. It fails every single time. Fairly sure that's the right incantation here. If m equals 1, return n. If n equals 1, return m. N is if m if n is greater than n, else n. For I in range 1, m plus 1, I want to do tot plus equals self.unique paths. I want to do it for I n minus 1. Whoops. Return tot equals 0. Right. I'm a little rusty on my Python, so let's just double check this. How did that happen? I want, so print I m minus 1. Let's see what on earth is going on here. 626. Oh. My base case is wrong. Those are meant to return 1s. Dooey. That'll put me out by quite a lot. That's better. I have no idea where that came from. Okay. Use example test cases. Oops. I wasn't meant to click submit. Woohoo. It worked. Fantastic. Why didn't I get a daily? There we go, I did get a daily challenge. Let's just submit that again so we can see. Leetcode broke. Runtime surprisingly long. I guess it's this thing here, LRU cache. There's probably faster ways to do it. There's probably a solution that's just purely computational. As a closed form solution, but I don't know what it is. So I think we'll leave that there today. Thank you very much for watching, and I will see you next time. Bye.